Hello and welcome to another live stream here on Mikey's Flightdeck. Yes, last weekend we had already a live stream and now again, just 1 week later. But the topic here is important for the upcoming videos and the next step here in the cockpit project, and I had to do it anyway, and so I thought it is a good idea to let you join this here, and maybe some of you can learn something from my workflow. So, who's already here in the chat? Javier, hello, nice to have you here already. Atakan, hello, and how do we pronounce this? Sasquatchy, hello. Yes. Right, you're right, an interesting topic, and also new to me still, because making pedals or even using Fusion is new to me, and so excuse me when I'm a little bit slow here sometimes or don't use the best or most efficient way to do some things here. I'm still learning. I'm doing my best to come out with a finished designed panel. Flaviano, hello, good to have you here. Thank you for your comment. Yes, so let's go directly into Fusion, I think. And something I have to say, it's fantastic to have the possibilities now here to make those live streams. Many years ago, it was a privilege for only big TV shows or something like this to have this. And today, everyone can have a live stream and bring content to the audience. That's fantastic. So let's prepare this here. And we have already a sneak preview to something that I had to do. And this is a redesign of the Pedestal box. Yes, I know panels is today in focus, but panels require a box to hold them. And when I was thinking about how big could these panels be and how can they be mounted, then I came out with a method I have used already when I was making the panels for the overhead with these cross dowel nuts here. And these are drilled in here. The nuts are sitting in the wood, and a screw comes from the top and is fixing the panel to the structure here. And I came out with some problems when I make all the sides from 10mm MDF. You can see it still here. I have to make half the hole in this side of the panel, not the panel, the box, and the other half into the covering. And I thought a lot, how can I solve this? And now, just 1 hour before this stream, I came out with the idea of making a thinner wall to the both ends, and you can see the result. The hole here is free, and even this hole here, and so I can insert the cross dowels later. Yeah, so you see, even if I have brought out the pedestal video as my third video here on the channel, I still have to redesign it because I have learned new techniques, and before I have built this pedestal box just to know how big the cockpit is, how everything can be arranged in the room. Yeah, and so I have to build a new version of this the days. Yeah. Okay, but let's come now to panels. When you want to make panels, which panels? Let's have a look here to a picture, a bigger picture. So this picture is the open cockpits pedestal here. I hope I can use this here as a reference. Everything is really clean designed here and arranged here. When you are looking to real Boeing pedestals, then really I think you won't find many pedestals that look the same. During the years, the different manufacturers or the companies have arranged different kinds of panels. Some have a telephone built in, a printer, or they have a third radio in. Yeah, really an adventure to find the reference you will work after. So, and I have chosen this here as my reference because it's a clean structure here. Most pedestals have these gaps here. So zoom in here, these gaps in between these panels. They are also there on the real pedestal. It would make things easier for me when I would build such a gap between the panels, because then there would be more room for the cross down nuts. And actually, when there are screws like here directly beside each other, then I have to flex down. Is it called flex down in English? With an angle grinder. You know, I have to shorten the cross dowel, one of them, so that they don't collide in these holes with each other. This is a lot of work, and I thought when I make a gap, then I can avoid this work. But when there is this gap here, dirt and can settle down here. I have this watched on my overhead. It's still beside me when I'm looking over here, and then I'm talking about my overhead panel. And it is here in my room. It's not the dirtiest room in the house here, but still there is already dust settling on this overhead. And this overhead panel is hanging over your head. So normally not much dust would settle down there, but this pedestal here is standing horizontally down, and it is in my basement where it is not very clean, and I don't want to know how much dust would settle in here in this gap. And I think it would be very difficult to keep this clean. Or if you clean it with a brush or something like this, then I would damage the panels over time. And so I have decided to not have a gap like on all the other panel segments on my overhead panel. So this was something I had to become clear before I start here. So, and then when you are designing such a panel. You can't just take one radio panel and design it, and after this you can think, oh, how could I make the navigation panel, for example. So I have to build an overview of how everything could be aligned in the future. You don't need to go into details, but you have to know how big this is with which you want to come out. So let's have a look on this now here. I have prepared something here. So, and there we are. Yep. This is high-end technique today, so different cameras in use here. So this is what I have designed here before. I have sat down and written down all the components or the panel segments that I want to build. The fire panel will be built, yes, of course, but it's not here because it is built before this box. It doesn't collide with any of these other panels here. There are panels I don't build this time. Here you have the 3 blank plates that are also blank on the picture, and this would be the audio selector panels, I think they are called. I have said this in my last live stream. I will not build these panels before I exactly know how to use them in my simulator setup. Some people are using this for changing communication frequencies. If there are some solutions that I can also control VATSIM or IVAO with this, then I think this could be a reason to build them. There are already also people who are controlling engine failures with the knobs. I think I don't want to use them for this purpose. So, but you can see it doesn't matter if the measurements are correct here. Just write down what you want to build. I have written down here how the width of all these panels, 147 millimeters will every panel segment have in width. I think this comes very near to the original panel. And then here you can see I have written down how the height of these panels. Luckily, these panels have all the same height, so 65 millimeters. All these 3 panel segments will have here. If I build this, I have designed with 120 millimeters. So not designed, I have planned to build this with 120 millimeters. There are smaller versions out there, 5 millimeters or a centimeter less. But I think if I will build this audio selector panel, then there are so many controls in this one panel. I will need every place I can get, and so I thought it would be good to make it a little bit bigger. 65 millimeters again for the ADF panels, 90 millimeters for this blank plate here, and 60 millimeters for the light and door panels. And here we have 2 other panels here, the rudder trim here, 95 millimeters, and the transponder with 55. So this is my thoughts written down, which will join me during this whole construction. Funny thing here, by the way, here I have my designs I have made for the overhead panel over 2 years ago, and believe it, I have never lost this sheet of paper. It would be it would be catastrophic if I would have lost this here. So every time I thought it's away, I have found it again all the years. So yeah, these are the thoughts now here about making these panels. Oh, any questions already here? Chat Real Rock, hello. So Flavio, you can always design from the picture by making canvas and follow the line, and you will be able to have those gaps you are talking about. Yeah, by having gaps, this will looking more professional, and you can always clean with a small brush. Yes, yes. I thought this too. It would look professional, maybe to all those who are in this simulator topic. They would recognize this as a professional look. Others may not think so, and I'm thinking which kind of people will be will spend more time in this cockpit. Yeah. If I change my mind by not make them one by one and have a gap between them, then I can still make the pedestal box a little bit wider. But I think this will not change the panel dimensions right now, so I think we can start the building here. Yeah, and let's dive into it right now. When I make this, I will have to make a little bit organization here. You can see here I have my panels here at the left, my folders. So I have made an overhead folder for forward and aft overhead, so on general parts here, knobs, what you need when you make panels. So, and I have already made pedestal folder, and now I will make one file for every panel I'm making. And today we will start with the communication panel. So make here, there we have it. So that you can see what we are developing here. And I start with a new file. Let's close this pedestal here. So, and when I will need a little bit more time to find some commands here. Normally I'm using the German version of Fusion. I have switched this now to English so that most of you or international audition can follow me here along. So forgive me when I'm searching some comments from time to time. So let's start, I think, with a sketch. We'll make a sketch here on this plane. And what have we said? 147 by 65. So 147, I have to arrange the microphone here. So 47 by 65. So there we have it, nearly finished. What will be next? I have that these screws here, they have nearly 10 millimeters or 5 millimeters radius, 10 millimeters at all, and the distance from the upper corner here, where's my mouse here, from the upper corner to the beginning is 5 millimeters. So I will now make some guidelines. I love these guidelines in SketchUp. They always help me. Here in Fusion, for me, it's a little bit more difficult to make guidelines, but I'm using them more and more. I think you just have to use them and become familiar with them. So, and now what I have said here, 5 millimeters, there we have them. it's already nearly 5. So here's 6, 5, yeah, it goes down. So just to have a view. And then 10 millimeters later, there comes the end. I'm just designing here my way. Nothing is really planned how I can do this. I'm just trying out if this can be a way to make this here. Before, I don't know if you have seen my previous live stream tutorial where I have designed a full panel in CorelDRAW. Yep, there I have also shown you the way to make a panel. So this will be here the first rounding. Where do I have my picture here? So I will make this over here. So here we have it. And I will make this, oh, I think not a circle, but we can use the arc, it is called, yes, arc. Will this work with this? I'm not really familiar with arcs here. No, I think I can't even reach this here. If it's not working, I'm making this with a circle. 3-point arc. Where I can't. Cool. I can't get over with the arc here. Oh, no, now I can. Okay, now I can try this, the other arc center point. Okay, I don't have a center point. Let's try this. And here, yeah, and okay. No, this is not what I'm looking for. I have to look in CorelDRAW again just to get some measurements. Or have I don't have those arcs on the next panel I'm designing. Just yeah, you see, it's good to have some references to other panels that you have made. Here I have them. I have to write them down from time to time, I think. So here I can see, what can I see? Nothing can I see. 10 millimeters, okay. I thought this is 15, okay. Let's have a look here. From 0 here, this. Just have a look, where is this here? Here, nearly at 10, okay. 10, okay, it goes 10 millimeters in and yeah, nearly 5 straight, okay. You think you are making panels all the time, but then you forget most of it. So I will start my half circle 5 millimeters away from the corner. And again, I'm using some guidelines. We'll see where this will end here. So, and a 3-point arc. I think this has worked good last time. Yeah, it shows you when it would be a complete round circle. You can see the symbols here. There are these symbols, no? When I go here, it snaps in. Like this. So, but now this shouldn't be a guideline. This should be a real line. And also this here should also be a real line now. Jump. Up. Later, I think we can mirror this, so we don't have to design this on the other side too. I will cut it in half and then mirror it. Forgive me, guys. I'm really concentrated here in designing these panels. I have to look into the chat from time to time. What have we here? Here, called data printer panel. Yeah. The printer, I know it can print out here these weathers, or is it called acres messages here. Jet Wheel Walk, thanks for your help and tutorial. One question: is engraving or lasering better for backlighting? Forgive me when I'm answering here in English, so all the others can understand it too. It doesn't matter, really. Lasering gives you, I think you can get smaller and finer when you want to engrave text. But the end result, how the light is coming through, there is nearly no difference. I think engraving is making cleaner grounds of the engraved text, and so yeah, maybe it can look even better, but you can do a lot more, and this is the most important reason, a lot faster with lasering than engraving. I need a time of half an hour, 45 minutes for, I think here it was the pressurization panel, and lasering, it took me around 8 minutes. So the difference from routing to lasering. So yeah, yes, Javier, you can make a circle and cut it to half. Yeah, that's the way I have done most of the time. You run sometimes here into problems with Fusion, because then some how is it called here, constraints don't work anymore, and you have to make other constraints, and so yes, cutting forms to half is the easiest, but not always the best solution you can choose. So again here, I could also mirror this, you know, it's completely the same. Come on, let's make this. This will be training. Another arc, 3-point arc here. And this time not a construction line, a real line. There we are. And we're making this to be a real line. And now we're cutting. We're using here our trim tool. And what we do is trimming everything away that we don't need. This, it shows you with red what will be cut away. Here, these can also be away. So, and there we are. Now we can also delete these guidelines here. And I think this measurements come in handy already for this to keep the circle in place. The goal is always to have a fully is it described or constrained sketch. This is looking a little bit different, or what? Or am I looking wrong here? Here, these are different, I think. Let's. What do we have here? These are 5mm, and what is this here? These two circles are looking different. Do you see what I have? And these are only 3. What's this? Have I forgotten something? Let's make this again. Come on. Yeah, I can extend it. So I think I have forgotten to place it 5mm away from the corner. 5. So, and now the arc. There it is. Yeah, this is looking better. Okay, and get rid of this. And get rid of this. Yes. And here we are with the 2 circles of the left. So what have we said? 147 millimeters, and we will cut this in half. You can do this just by inserting divided by 2. And we will delete this here. And here we are with these warnings. This is what I have called, what I was talking about some minutes ago. You get warnings because this is a rectangle, a fully defined form, and now we're cutting away something, and now not everything still works here in this. But I think for our purpose it will work. So now we'll make center line. This is a center line, and we will use this center line to mirror everything. And I mean everything. There it is mirrored. So now all these constraints here are really overwhelming when you not want to see them. You can go to the display settings and object visibility, and we don't want to see, where are these joints? All working features not. Somewhere you can switch out. Here, show constraints here. There it was here on the right. Don't delete the center line. Convert it to construction. Oh, come, we have the time. Come on, this I want to see if this works. So I don't want to delete it. Cool. Yes, this works too. Thanks. You see, when we are working together, we can reach everything. Thank you. So, and now I have to select the mirror line. Oh, this is cool. Yes, and we don't get these warnings. Cool. So, show constraints away. And here we are now with the first rough panel body. Finish the sketch. And there comes the next. Are here really the Fusion pros in the chat? You can just press X for this. I'm not really good in all these shortcuts here. Yeah. From construction and back by only using the shortcut X. Oh, this is cool. This is so cool. I will write this down. Guys, wait. I have to write this down. This is so cool. X. So construction to normal. No? I just call this. Okay. Great. So and here I can see we have to delete these other lines here. Can I now delete them? Here, cut them away. Zip. Up. And is it mirrored too? Hey, why not? Okay, come. Here I cut them away. So there we are. And now this is the moment when I extrude this and I want to see how it looks. All my panels have a thickness, my acrylic sheets of 3 millimeters. And there we are. Oh, this is always a good moment. It makes it more realistic here. By the way, camera, is this to perspective? Yes. By the way, when you want to know how I'm changing my view here, I can show this to you. I have written this down somewhere in the chat on another channel. I'm using these 3D connection 3D mouses. Here, I show this to you. Here you can see this. Not right now. Oh, now you can see this. This is the mouse I'm using, and you can change the view. Can I bring the view to? Yep. One moment. No, not really. I will make this like this. Oh, like this. This is really rough. I have not designed this too good here. And so you can see when I'm moving this, you can see I can easily move around my object. And this even works in sketches. Here, when I go to the sketch, I have a button that can disable the 3D options, and so I can now move in 2D, and so I can get really fast to the places I want to get. And when I'm then back in 3D, just enable the 3D options, and I can slide around here. So really cool tool when you're using much 3D programs here. So yes, you need some money for this mouse. My first 3D mouse now I had over 10 years now. 10 years ago, when I was a student, they were really cheap to get because the university has bought a lot and sold them for a small price to the students. But they have become really expensive these days, yes. But for me, it was a time to switch to a newer version here because the old one wasn't supported by all these programs anymore. 10 years it was in use, and there was never a failure. So these are very durable. What did you study? I guess some engineering. No, not engineering, informatic, computer science called. And 3D and filmmaking was a part of it. I don't know much anymore because now for years I'm working for an insurance company. But when I started studying computer science with the centered topic on 3D and film and so on, I thought I could make the next Harry Potter film. But things come always different than you plan. So, but back to panel making here. Here we have the panel nearly finished. And when you already want to apply some color here, then I use this. I have saved this as a favorite here already. I think. I was thinking I have saved this. My RAL code. I haven't. Where I have it here. Plastic matte. Is this here? So let's look up the, let's take it like it is. So later you can just Google RAL code to RGB, and then you can insert these values here. It's just for rendering. Later you paint it the color you wanted. So we use this now. So here we are. Now let's go on. What will we need next? This hole for this the 7-segment displays, I think. Yeah, 7-segment displays I have modeled and measured. Yeah, of course I have measured them, otherwise I couldn't model them. I think I have them here in general parts. Yes, here, 7-segment displays, just roughly modeled to use them in my designs. It shouldn't look good, it is just for seeing if anything collides with another thing. So what do we have here? Distance 7.5 millimeters in width, and I think it was 14 millimeters height. So back to our design, back to the sketch. How many segments will we need? 6. So when we want to use 6 side by side here, let's go on the calculator. We have 7.5 millimeters for one, multiplied by 6, and we come out with 45 millimeters that we will need. So 14 by 45. And now we come to, we have to be careful now. These would be the place we will need for the 7-segment displays. I'm always a little bit careful here and make the cutouts a little bit bigger. Let's have a look, because I don't remember exactly how much bigger I have to cut this. I think something like 0.2 millimeters on each side. Let's have a look to the upcoming panel here. Overhead, forward overhead. You see, I only have one design here for the forward overhead because all the other panels are designed in Core Draw. Here we have the here we have the upcoming panel. Somewhere is a sketch visible. So yeah, and you can see when it is finished, then it looks like this. All these cutouts here, and the PCB where it will be later, the backlighting panel, and other components. I think when you have joined the last live stream, then you have seen this already in an early construction stage. So, but back to the opening for the 7-segment displays. I hope I can see this here. So get rid of the top. There we are. And let's take a measurement of this line, 38, and we have only 5. So have a look. 7.5 by 5 would be here 37.5. So I have added 0.25 millimeters on each side as extra space. So back to our design. 45, I think I can do it like this. Yeah. Why am I doing this like this? I'm adding plus 0.5 millimeters. I could write 45.5 millimeters here, but when I write this down in this method, I can see, yes, originally I want to have 45 millimeters, but I give some extra space here. And so this is more clear when I review these designs here. Oh, and the same here. Additional 0.5 millimeters. So just a short view to the chat here. Shortcut T to delete. Yes, thank you. You can add the hole in the same sketch. Yeah, this is what I'm doing here, right? Do you use a paid version of Fusion 360? Is it really needed? No, I think for most of you, it's not needed to have a paid version. Years ago, they had the regulation that when you have only $100,000 income, not earning, I don't know the English word for this, no, what you receive with all your sales before you make all your taxes and your and the bills and so on, then you didn't need to pay for it. Now they have the option for startups. Just go to the website. It's some value that you have to be under it on earnings a year, and then you can ask every year for a startup license. And this is what I have done here. I'm far underneath these earnings. I don't know how much, and so I have received the startup license. Yeah, and when you are using it as a hobbyist, then it is free too. The link for the mouse. Just just Google 3D connection here. I give you the link here to the manufacturer in the chat here. There it is, and there you can have a look what items they have. They have these smaller ones that for beginners. Even this has become really expensive. It cost I think nearly 50 euros when I had my first one, and now it costs nearly 140. So the prices have raised enormously. So yeah, we go on. And where do I place this? Sure, somewhere here underneath. In the middle of this screw, somewhere here. We will see. I make it, it's not fully defined now, somewhere here. Just add a dimension here. Let's say, start with 10. A little bit more. Let's make 12 millimeters. I think this is not too bad. And here, let's start with 18 or only a little bit nearer 17. Something I have to keep in mind always here when I'm designing these things. I have a 10 millimeter MDF board here on the side. So with every components that I have to that I want to insert here into the panel, I have to be away from the sides. So just to remember this, we will add a guideline here. And this guideline isn't straight. Let's place a straight guideline here. So like this. And this guideline should be away 10. Let's make this 10. These 10. Yeah. So just to keep in mind where I have to keep out. When I'm making my backlight panel that sits behind there, I use 12 millimeters as a distance from the side, and 16 millimeters there I place my screws that here join the 3 panels with a backlighting panel. Yeah. So here, there it is. Now I think, because we have here, I know I always forget this, to work more efficient. It makes a lot of sense. So let's stop this here and use components. I wanted to keep this in mind. Maybe it will work still. So every unit, I will call this here. So every layer of this panel, bottom, middle, top panel, will be a unit. Every knob, every button, the backlighting panel, and so on. Everything will be a separate unit. And here this is called component. So I make a new component. I think, yeah. And I hope I can bring these pieces into it here. The sketch file. Yes, I can do this. No, and yeah, there it is. Okay, here. And we will see the advantage of this method later, because when we are here in our main component, with the root level, I would say, of our construction here, then the list of commands we have used will be very long, very long. The bigger the panel is you are working on, the longer the list of commands will be. And when we are split it down into smaller components like this here, then it will only show the commands we have used for this single component. And this will be not as much commands. And so you can redesign things faster. When you see, oh, my extrusion of this panel must be 1 millimeter more, then you can go directly to the extrusion you have used for this component. I think we will come to this later. Be prepared. This will be a long live stream, I hope. I hope I can stay awake. So, back to the sketch. And here, mirror this hole too. Yeah, and here you can see I don't have the mirroring command. No, we'll make a new mirror. Mirror, and the object will be this here, and it is already mirrored. It has selected the line automatically. There it is. Finish the sketch, and down here we double click the extrusion, and we can say, just click here, these things will be spared off. There it is. Fine. I'm always rotating sometimes around here. I have to think not to do this now, so this is not very interesting for you, but I like looking around and see how this panel grows and grows. Yeah. So, and again, where do we, the 7 segment displays, placing in there. Now I go to the root level, make a new component, add a container for all these 7 segment displays. Here you can't do something like folders here, so you do components. And I call this displays. This is the main display component folder. I make another component, and I have to look that this component here is checked. So I will create a component in a component now, and call this displays left. And we will make this later. I will create a component displays right. I think we will do this after this. So, and into this component displays left, I now drag these 7 segment displays. I hope I do this right. Ah, saves the design. Yeah, okay. Sure. This is always a good idea to save your designs. We call this com panel. But not into general parts. Cockpit. Where we are here. Pedestal. So, and com panel. Right. So, and now import this 7 segment display. There it is. And now we have to place it where we need it. And this, there are several methods to do this. I think when I use the align method, it works really good. Just hit S, not now, later. Just hit S, one shortcut I know, meanwhile, and it is called align. I have looked up the English word before. So when I align this center with to this center, and with this alignment I have made clear that this is between these two sides here of the cutoffs. And okay, and now I have to move it a little bit away. This one here, and 0.25 millimeters. So there it sits. We will see in which height it will sit later. So, but now we need 5 more. And we have to go back here into our display component. And now use the rectangular pattern. I think this is the wrong command. Capture position. No, capture position. I have to click. So, and now again. The rectangular pattern for components. This component here. Is there a direction? Yep, direction. This one. And a quantity of 6. And in the other direction only 1 here. So, and we will do this via the spacing between the components, because there shouldn't be any spacing. So how much have the distance to be? I think the width of our 7 segment display, which is 7.5 millimeters, but negative. Yeah. This is looking really good. So there we are. 6 7 segment displays. And now we will, I'm thinking if I can just copy them. Yeah, and then I just call them displays. No, this wouldn't be a good idea, because when it's not clear where this opening will be finally, and then this wouldn't work anymore. So I just make a copy of them. Yeah, I make a new component. New component I call displays right. And yeah, now have to go one step up again and use the move command. And components here, select. So here I can select them here directly. This whole component. So, and yeah, how much I have to move it over? I should measure first. I will do this here because I can see better then. So from here to here, the distance is 22 millimeters, and the whole component has, I think, 45, I remember. 45 and then 22 and a little bit more here. Okay. So I go in there, select displace left, M for move, and say create a copy. And now, yeah, my move anchor is down here because I think there was the point where this component is. Maybe someone of you knows how I can move this. I think this is the pivot point and I have to set it just here. I always don't know. It's very annoying from time to time. Maybe you know this. Then I would learn again something from you. So over here, 45, not too bad. Additional 22 here, and I think additional 0.25 millimeters. So let's have a look. Over here. No, not, we have 0.5 to take as an additional. Can I do this here? No, I can't do the move command again. Okay. So again, display left, move 45, additional 22, additional 0.5. And I have forgotten to say create a copy. And again, always the same. Create a copy 45, 22.5. And now I hope finally we have it. Yeah, a little gap here, a little gap there. There we have them. Okay, I think I can't rename these here. Or can I? No, I can't. Okay. Yeah, if you want it independent from the others, then you have to insert it again as a new component. You can do this, but I think now I will go with this. So what have we here in the chat? To make your life easy, before you start working on Fusion, make sure you create first a component, especially when you are going to create big files and afterwards you will be having to combine them. Yes. Yes. This is the thing I forgot when I started, but I think now we are on a good way here. We have now components of everything. Yep. So here, and then we can already think about some more holes here in the panel. Yeah. The button, the COM button. Do you see this? I have to, yeah, the COM test button. Normally, I'm using these smaller buttons. Where do we have them? Here. You can see these. Here I opening it. The push button. Yeah. By the way, not every component here I'm using is made by myself. There are a lot of free libraries you can use. Some components I have adapted to my needs. I think this button, especially here, isn't made by myself here. And so this button here has an opening, whatever here, radius nearly 3, diameter nearly 6. When I look other designs up, I think I have made an opening of 7 millimeters around for this. So, but now it's the question, will I use this, or will I use another button and have this on top of a tactile button? Tja, good question. I think, personally, the easiest way would be just to use a standard push button, the one I have showed to you here. Otherwise, I would have to expand the PCB here so that I can solder the push button here, or I have to find a way to mount this push button in here. And I think it's not too important if this push button is now here. Maybe how big may this be? Maybe 10 or 8 millimeter, or if it is 6 millimeters in diameter, and I can use a ready-made component. Yeah, I think I will go with the normal push button. So I go back to the sketch here, and in the middle I make a hole of 7 millimeters. Just to look this up here in CorelDRAW. Yes, here we have such a push button. And what are we designing? Which part right now? I think the bottom part we start with. Huh? And here I have a diameter of 7 millimeters. Yeah, right. Okay, 7 millimeters. And where will we place it? So a little bit more down, I think. One more, 15. I think here, something like here. Okay. So the next opening here, let's go for this opening of the button here. I think this button will be placed on the PCB. The PCB will be somewhere behind here because it has to carry all the 7-segment displays and manage all the routings of the cables. And this push button here has to be backlighted. And so it would be, I think, the best decision to use the push buttons I've used on my IRS panel. And so I can use this, design a button cap for it, and mount it on top of it. And then this will work. What is a little bit sad, I haven't said this in the video of the IRS panel, I forgot this. The color of the light differs from the LED stripes. So my LED stripes are warm white, and the light of the push buttons are white. I think cold white. It is. You just can order them in white, so you have to take what you can get. And so the color of the button will be a little bit different than the overall backlighting color. But I think I will have to live with this. Yes. How big can this be? A centimeter, I think. Yeah, and we are talking about the opening. It looks bigger in the panel. Let's start with 14. Not the height. 14 the width and height. Let's make 10. Just trying. So. Yeah. And we have to place it in the middle. So it would be better but we can't convert it, no? When we use a rectangle, a center rectangle here. So we have a point that we can align to the middle. So again, 10 and 14. And now we can here align this point to this center line. So, and it has to be aligned on the middle point of this, and we will use to align this a point here, and make a, how is this called, a horizontal constraint here. Zack, and it's sitting in the middle. How does it look? Not too bad, I think, huh? Yeah. When I compare this to the panel, I think it's not too far away of this. 14mm is sounding really big. Sometimes it's good to have a measurement tool or just a ruler to see how big. Wow, and 14 is big. Oh. Okay, let's try a little bit smaller. 12. But then we have to go smaller with this here too. 9. 12 by 9. Yeah, definitely better. I'm just looking right now how big the panel will be. I'm really not too sure how big this should be later. Let's stick to these measurements for the first try. The good thing is that you can change them always. So what have we here? You can use the function pin to get you display fit in the hole. Which display? Ah, you mean this display here? Okay. Yo, and so yeah, the last hole we would talk about here would be this hole of this dual rotary encoder. And there we come to the next problem. I haven't designed a dual rotary encoder until now. There are some ideas in my mind. I have looked up some other designs of other builders. I think I want to come out with a solution where the two encoders are sitting really tight to each other. So there are designs that are really big, 3D printed designs. And I think I can't use too much space behind here. Luckily, there isn't too much backlighting in the area, so the encoder around here isn't backlighted, so I think I have all this room here for the encoder. But I think for the future, everywhere where dual rotary encoders will be needed, it would be always better to keep a small footprint of this component. And so I don't know how this encoder will look like at the moment. I will design it later, not today, but I only assume now a size for the hole. And normally for all these encoder holes and so on, I have used 12 millimeters until now. So we just assume these 12 millimeters, and then we will see how this will come out. So let's say X, not now, shortcut X, I have remembered it, huh? Cool. So it's a right line, a real line, sorry. And it looks to me like it is the same horizontal height here as the other hole here. And so we make a constraint. Have I done a constraint now? Yeah, I have done it. Okay. And the distance, something like this. Let's start with 30. So finish the sketch and go back to the extrude. Yep. And here I can already show you what I have talked about before. Now we are on the root level of our design. You can see down here the commands we have used here, and when we go now to our panel component, you can see there are only 2 of these commands left, and this effect will be much more helpful to you the more commands you have used on during the designing time. And now I can directly see this extrude is what I need now. Double click it and make the next cutouts. And back to the root level. There we are. So, Javier, what do we have here? But you can do acrylic laser cutted gears for the dual encoders and allow the backlight to pass through. Yeah, yes. This is right, but they the encoders can't do. Okay, when I make it very long and so that the light can come between the encoders and everything, I not only want to I want to have everything really narrow to each other. Yes, laser cut gears. If I will use gears, yes, I will laser cut them. Because they are very fast made. I will see with what I will come out here then. So this will be the bottom. We can name it already. The bottom part. And now we can already design the top part, the middle part. I think we should come to the no, this is not the bottom part. This is the top part because of these cutouts here. Only the top part has these cutouts. So here we are, and now we can design the let's go down here, the middle part, and make our way through this here. So a new component, call this middle. Middle. There we are. Can we move it between these? Top. No. No, we can't. Okay. So the middle component. And again, we start with a sketch. I will turn this around. I'll make this like this. The sketch will be placed on the back side here, this panel, but no. Can we turn it like this? I think, yeah, I want to have a look from the top on it. So camera's orthographic, okay. And now, to not draw everything new, we can use the, what is this called in English, the project function. So first of all, the rectangle we can draw. Here we have it, 65 by 147. And for the cutouts, we can use the projection tool for, yeah, not all the cutouts, but only these things. Ooh, stay on top. I want to use this here. And the advantage of using these projections is that when I'm doing any changes, I can't get it. When I make any changes to these cutouts in the component where the projection comes from, then the changes are brought to any other components that use this projection. So you have to change it in one component only, and all the others take profit of it. I think I have made this here. Okay, and these cutouts here. Come in. I can't zoom in here. There. This one. Oh, that was too much. Nope. Oh, really hard sometimes to hit the right line that you need. So this one. And I have seen that projection also slowing down your design a little bit from the performance view. So I think we have it all here. So we have to place some other holes here, and these are the holes for the screws here. And it is 4.5 millimeters in width. I'm using 4 millimeter screws, and to have a little bit of play, I'm using 4.5 millimeters here. I think it is already placed right. Let's check this. This should be 5 millimeters away from the corner, and it is. Yeah, because it uses I think the point here. Oh, it is defined already. Cool. And another circle here, 4.5 millimeters. Should we use again the mirroring? Okay, come. Come. Let's just come on. Let's just place these circles here. 4.5 and last circle 4.5. Yes. Finish the sketch and just have a look. Okay, there. We have to do now the extrusion. 3 millimeters. Yes, but with these two. Yep, there we have it. Maybe, no, I'm thinking if we could have used the other sketch. No, we can't, but because it is in the other component. Yeah, new body. Okay. There we are already with a middle plate. Yeah. And this is something I really like in designing in 3D, because when I'm designing the different layers separately from each other, then I now can see if some holes aren't aligned correctly to each other. Huh? When you look at the upper and lower hole here, you can see the lines are the same. Okay, they are the same because we have projected them from each other, but you get the idea. When you make something different and you bring it into your design and want to align it right, then this is a cool thing that you can look if all the holes are aligned correctly. And now I see something we have to change here in our sketch. This circle. This shouldn't be projected. I can tell you why. Hello, I want to delete this. Thank you. The cutout in the middle panel has to be bigger than in the other panels because of the nut that holds the button or the switch in place. I think I will design the dual rotary encoder the same, that I can screw it here. I really don't know it at the moment, but it would be cool if I can design it this way here. And so to have room for this nut here, this circle has to be bigger. And is this already right here? Yeah, I have used 19 or 18, I think 19 millimeters as the size of the cutout here. It hasn't projected it. I think if I would use a projection here, it would be more helpful. So I just click P for projection and just, is this possible to project just the point? No. Okay, so I project this circle and use the center point as an anchor for the new circle of 19 millimeters. So back to our middle component and the extrusion, and there we use this. Yep. There we are. You can see now a bigger hole here for the nut. You can give it a color, the same we have used here. we have the middle plate. Later, the panel, I think the panel won't be painted completely to let light come through. I mask it out mostly and just paint around it so that these parts here, this open part here is lacquered, and a line around it so that the borders are clean. Here, and now we can have a look at the bottom panel. And I think we can use the sketch of the middle panel for this. So make a new component, call it bottom. There we are. And we make a new, can we make a new sketch? Let's try if we can use, we will make a new sketch, it's okay. So down here. And again, we want to be on top, the top view. So there we are in the bottom, and we will project let's get rid of the top panel. Yeah, here, this is, we want to project nearly everything. Yeah, just click here, say projection, and now let's change this circle. This is the one that we will there we will make a new circle in here, and this will be the, again, a 12mm circle, a smaller one. And I forgot, this one has to be bigger in the middle panel too. Let's first finish this sketch and finish the bottom panel here. Where we are. Just have a look here. So we have to come from down here. So into the bottom panel and make an extrusion. And yeah, use a small one and 3mm. There we are. And add a color. There we have it. Cool. So we have to come to the middle panel again, and there to the sketch, because this cutout has to be bigger too in the middle panel. I have to look up how big. Here's the design of my this LED devices panel, and here I also look at the middle panel, and for these small buttons I have used, you can see 12mm, so that the nut fits in here. So make a new circle, use the middle point as reference, say 12mm. There we are, sketch is finished. And again, what I said, you can see a lot of commands here, and when we go to the middle component, only 2 commands are left over, and so it's easier to find the command you want to change. Make a bigger cutout here. And back to the root. There we are. Oh, now something has gone wrong. Now the hole is closed. Back to the middle panel. And to the extrusion, something has gone wrong. The hole is a big one. Okay. Where is the hole closed? In the No, it's a big. The hole is missing in the bottom panel. What's going on there? Sketch. Have I just... the hole is here. Have I just forgotten the extrusion? Yeah, I just forgot the extrusion. Ah, there we are. But it should be not the big one, it must be the small one. Why is it, has it become big now? Okay, back to the sketch of the bottom panel. And project the small one. Okay, and get rid of the big one. And to the bottom panel and to the extrusion. Yeah, now I can choose a smaller one. Oh, and now again. Yeah, now it looks right. Here when we see in here, the top panel and the bottom panel have the same cutout size, and the middle one, there is the bigger one. Yeah, that's how it should be. Okay. Yeah, looks like a good panel. And now we come back to the 7-segment displays, the alignment of these. I think it's looking much cooler when you are inserting some smoked acrylic glass into these, on top of these. So they are hidden when they are dark, nearly hidden, and visible when they are illuminated. So for this, we have to lower them. I get rid of the top panel here because I want the upper line of these 7-segment displays be in the same level as the upper line of this middle panel, so I lower them. Maybe we can do this easy. So displays all are marked, and now I use again the align command, so just S for shortcuts and type in align, and I align. Am I only aligning this one component or all? Just try it. Yeah, only this one. Okay. Can we do this now? This. Yep. This. I hope this works. I can't. Can't I use more? Only one? Okay, we will make this in another way. I want to move this, and we will measure. Maybe just measuring how much I have to move it. The distance is 5.75 millimeters. So just move them down minus 5.75 millimeters. Capture position. There they are, where I want to have them. Okay. Top panel again in, so there they will sit later. And now I think some roundings would be cool here, fillets in these edges. This edge. Not, we will make this not here, we will make this, when we do this in the sketch, I'm thinking just here, no? Follow my thinking. I could do the roundings in the sketch, but we have projected this, and then the roundings would also be on the middle and the bottom panel, but then there could be not enough room for these the edges of these segment displays, and so I will do the roundings here. But don't forget to go into the top component here. I'll make the roundings here. The fillets. Yeah. This edge, this, and also these here. Like this, and last one here. So how much? Not much rounding. Not much. I think 1 millimeter is already too much. Oh, let's try 0.5 millimeters. Difficult to say. What would you say? 1 millimeter or 0.5? Let's compare this to the picture. Just zoom in here. I think the millimeter is better. Yep. I will stick here to the millimeter. Get to the chopper. Hello, Michael. I hope you are doing well. Yes, I am. Late now, but I hope we can come here. Javier Enrique, 0.5? Come on, let's do a poll. Or 1 or 0.5 millimeter. Everyone who wants to have 0.5 millimeters saying yes, every other saying no. Just fun. Okay, 0.5 and 1 for the button. Come on, okay. Now we're here, interactive designing the fillet. Okay, I will go to 0.5. I'm starting a new job next month, aircraft handler in EDD Cologne, right? What is the aircraft handler? Handler, it's not the seller, no? Handler, so handling an aircraft on the ground, I think. So, and 1 millimeter for the button, yeah. The cutout of the button, yeah, we can also edit this. Okay, yeah, okay, we make 1 millimeter for the button. External power, so we have one here now, handling external powers to the aircraft. You are the one with a big plug. 1 millimeter for the button. Yes, sadly here in Hanover, I'm just living 15-20 minutes away from Hanover Airport EDD-V. And there was a possibility to have brunch or breakfast, and the restaurant was sit directly over the restrooms or openings of all these marshals and handlers, when you call it like this, and they go out and to their to the van for pushback and passenger cargo and so on. And every time when these guys are coming out there, they make a really relaxed opinion to me. They are looking very relaxed, so they are not in a hurry. I think it depends on the airport. I think Cologne is a little bit busier than Hanover, but when you have seen these guys coming out, I hope they got paid by time. Yeah, a friend of mine has worked as a handler for the passenger cargo and so on. He has put all the stuff into the plane during the night times during his study. Yeah. So, and now back here to making this panel. I think I will insert here another body, not a component, a body here. Broken Brain Guy, $5. Thank you for this. Thanks for all your content and sharing with the community. Your channel has been a great resource in my own build. Thank you. This is why I have done or started this channel here. I know the times when I was first thinking about making this cockpit stuff here, 2004, 2005. The first big content out there was the Norwegian 737 project. YouTube was in the start position, not too many videos out there, and resources to build this were very hard to find. But now more and more channels come out and showing detailed how things are made. Yeah, I know I love these videos, these short 30-second, 1-minute videos. I have talked about this very often, where you see a button, a hand coming into the screen, pushing this button, and then the camera moves to the computer screen where a button flips, and then the video stops. What is this? What is this? Yes, you have made it, but how have you made it? And when you look down at the comments, there are these questions. How have you made it? But these questions were never answered. And I thought I can answer all these questions here. So again, thank you. So let's make this acrylic sheet here. How will we do this? We have to be in the top component here. And yeah, it's how may we go to the extrude, to the extrusion here, and no, not to this extrusion. We make it another way. We do a new extrusion. There we have it. We have to activate the sketch again, and yeah, there we get it. Here it is, 3 millimeters, and we don't say cut or anything. We say a new body. I think this will work. New body. Here it is. It has these sharp corners here. We can round these too. let's make this, yeah. Now we have to name these bodies, right? Say here, panel, and this component is the glass. So, and deactivate the panel. So, and make these roundings. There, 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 and there. So, and by the way, 75% of the viewers have chosen the 0.5 millimeter corner. And so I'm making how the audience said, 0.5 millimeters. Here you are. So I'm not thinking now too much about a little distance between these two parts. Normally, when you want these two parts to fit into each other, then you should make some thoughts about this. But I will cut it out on my laser later. And every machine needs a different setup to come out with a perfect and tight fit. My machine, yeah, needs something like 0.12 or 0.14 millimeters. So if I would follow the line directly, or if I would give this DXF file, what we come out with later, into my laser and follow this line directly, then the glass would come out a little bit too small. And so when I'm, come on, I can show this to you here. When I'm using this in my laser software later, I will add a little offset, so cut it a little bit bigger. But this depends on your machine. And so I think when you build a cockpit, you should think a little bit by yourself too, when you are using your machine, how to use my designs or a design you do. Let's open a recent file just to show it to you. The IRS panel, yeah, this is a good example, not the PCB panel. There, this is my yeah, you can see it. Okay, this is my IRS design panel, and here we have also a cutout for the glass. And when I now cut the glass piece, no, you can see the red line is the cutting out of the panel. And when I now here it is, the glass piece there. And when I now want to cut out the glass piece, then I'm using the same design, but ungroup. Then I'm just pulling out this thing separately and delete everything else. And then I'm adding a small, there we have it here, an offset. And we have to zoom in very, very tight here to see this. Now you can see an offset to the outward as a distance of 0.14 millimeters. So I make it a little bit bigger, and then I cut it out. And then I come out with a perfect fit. This, yeah, okay, no saving. This is different when you're using a CNC router. The CNC router will take this line and route out really the outline of it. And then I think you can use it as it is. Maybe, yeah, to come out with a tight fit. So you have to know your machine that you are using. So, and now add another piece here. We can again use, I think, the move tool. Create a copy. And again, our mathematics. 45, I think. 22.5. Looks right. I remembered it. So, and now we need a little bit material here for these. Is this polycarbonate clear? I don't know what I have used here. Oh yeah, looking good. It's looking a little bit weird because the 7-segment displays are placed a little bit too high. They are colliding with it, and I'm lowering them just a little bit. Where is it? Components here, the displays here. Minus 0.1 millimeter. I think this should be enough. Yeah, there we are. Oh well, this I love, this shiny effect here. So, and so we come out with a nearly invisible 7-segment display when it is turned off. So, top, middle, bottom panel. Let's come to some engravings to make it look even cooler. What do we need? We need some letters, active and standby. What have we in the chat? Fusion is so boring in selecting edges. Why we can't easily loop a ring edges like in 3ds Max. Oh, I have worked long time with 3ds Max. Yeah. Sometimes you can you can do it when they are connected, no? Double click and then you can connect these. But right, there was this loops for these edges. I remember. Yeah, definitely a feature that misses here. And I don't know why, because 3ds Max is the same company, Autodesk, and why they aren't implementing this feature here. Yeah. If you have any 3D experience and then come to Sketch, it's a pain to relearn. I have CAD and Maya experience, and it's mostly unlearning and relearning just the sketch bits. Yeah, I can. Yeah, I have worked, I said it at the beginning of the stream, I have worked in 3ds Max and what was it? Cinema 4D. Yeah, but long time ago, and I'm really struggling, especially with modeling organic looking things like here, these buttons for the bowing. Yeah. Don't miss a hose for the spacers. Which spacers are you, Dennis? Which spacers are you meaning? The hose for the spacers. I have, yeah, make clear which spacers you mean. Yeah, now engraving. So again, active. Yeah. When you have watched my last live stream, I have said something about yeah, designing the font so that it can be used better in Fusion. I have brought chapters to the last live stream, so you can re-watch this. So I don't need to say everything again in this video here. Just watch the chapter of the last live stream, the birthday live stream. Just in short, Fusion doesn't give us too much options to work with text. Not here. I have to go to the top. Yep, this is how I do it. I go to the top and I make a new sketch. I have one sketch for the the body, the panel, and I have a separate sketch for the engraving. So I make it here on top. Yeah, capture position. So here we are. And now we can create a text. So text. And here you can see, this is all Fusion gives us to work with the text. It doesn't give us the possibility to use the outlines of the text or convert it to a real outline. Yeah, and what I have done to come out with a text useful for my laser, because it differs a little, not only a little bit, engraved with my CNC and engraved with my laser. There was a difference when I use the same file, the DXF file. And so I had to make the letters a little bit bigger. But this I can do in CorelDRAW with an outline. I'm just adding an extra outline around these letters, no problem. But in Fusion, I don't have this possibility. And so I have edited the font with a special program to come out with a font that I can use editors here in Fusion, called Flightdeck now. When you are watching for this font, it is called, let me have a look here. It is called MS, I think 5588. I look at here. It's called MS33558. It's a military font, and this is used here, or comes near all these Boeing text. So I give now my text in here, active. And I have written down the size. The next thing that isn't possible in Fusion is editing the font by points. This is the normal measurement of the size nearly every program uses, but Fusion uses height in millimeter. And so I have written down this here. I'm just looking it up again. You can't see it. I'm doing this on the other monitor. So there are different, should I show this here to you? Yeah, always good here. Just this is here the our NAS here at home, and I have a note station, and I'm storing some designs when I find them in the internet. Everything I think it could be useful in the future. Save it. You don't know if a website is always there for you, and if or maybe he closes the website, or you don't find it anymore. Save it, or even maybe even the link. Save it to any resource you can get. So, and I'm using 3 different sizes here. 0.9 you can see for the annunciators, and there are bigger writings on these panels. I'm using these 30 points, and 11 points are all these normal writings on the panels, no? When you have them around a button or something like this. And I'm thinking, if this active and standby is a bigger writing, let's have a look here on the panel. Is this here the same size as this? And I would say no. I think this is bigger as this here, or like these here. Yeah, and so I will use the bigger writing for these here. Yeah. So we'll do. So 4.66 millimeters. 4.66 millimeters, and text in the middle makes it easier to work with. There we have it. And I'm making it so that I can align it better. Okay, and later we will align it right. So just have a short look here to the chat. What's have happened here? Most of Autodesk software are bought by them. That is why one is cool and the second works completely different. Yeah, I know they have bought Eagle here, this electrical software, and yeah, fused it with Fusion here, so you could have everything out of one program. Not too bad, but I had my problems designing electrical components with it. So they haven't made many from their current software from scratch. Okay. Could you write the name of the Boeing font? Yeah, I can also write it. MS3355A. This is the font I'm using. So I can't share the font I have developed here because I think I am not allowed to share it. I can share the name of the font. So you can search for it. It can be found for free. And again, watch my last live stream, or especially the chapter where I'm showing you how to edit this font with which program. Then you have all the knowledge to design your own font as you need it here. So yeah, but in COM panel Futura font is using. I have used Futura font at the beginning too, but I think there are some. Oh yes, I see some differences. Let's compare this one by one. We will make this with an M here. I think the M. This is the one that you can compare the best. Yes, you are right. Here. So I think everyone can see this. The M. The legs of the M go outside. The M of all the other panels. Let's open my reference panel here that I'm using for the overhead, for example. Here we have it. Where we have an M here, temp, for example. You see the legs of the M go down straight. Yeah, so we have a different font here. Okay, next question. Okay, here I am again. Yeah, I can rebuild this here. It's the question, has real Boeing different fonts on these panels? I have invested now much time to get this font here. And I think it would look strange if I'm using one font at the overhead, one font, another other font at the pedestal. Tja. All right, Atacan, cool. Cargo panel is military font and also overhead. Yes. Oh, this is. But they have modeled it here. Okay. Have a look at the M here with the legs outside. At the end, the M here. Here we have the military font. Cool. Okay, the chaos is perfect. Yeah, okay. There we are again at a point where I say I'm building as real as possible but I have also my own line I'm following here. I make now the decision I will use this one font through all the panels. And yeah, I think only the real nerds would see that I am building right at the original, like the original one, when I'm using different fonts for these panels. Okay, I will stick to this Mikey's Flightdeck font now, developed from this MS 33558. Whew. So somewhere here, active, and now standby. Yeah, we can make a new text. We can also copy the text. Yeah, there. You have to be very careful with these handles here of text. You always think you can move or scale it, but you scale it to strange directions when you are doing it. Be careful when you are working with these text handles. Standby. There. Boeing is using their own custom font, I think. Yeah, I think too. But they aren't sharing it with me. That's why I just went Futura. I thought it visually looked close enough to be real font, but I know it's good enough. Yep. And it is also a font that is mostly available. Easy. Go with what you like. You can make your own panels. Yeah. This is what I do. And maybe some of you do their panels like me. It's always funny when from time to time I'm getting don't know how it's called, when people link me in their builds, and then I look on a picture on Instagram, and it's like I'm looking into my simulator, because they have used my plans and I have built this exactly like I have done. That's cool. Now I'm thinking, can I do this here with this font, or is this destroying it? Oh, it worked. Cool. So somewhere here we can make the exact positioning later. It's not too interesting for you now, just to let you know how I do the engraving. So standby and this VHF here. Bring it up here. VHF, but is this the same size? I think it's the same size as this here. Yeah. Okay, then arrange it, and later we will align it so that it's perfectly in the middle. When fonts or engravings are placed here, then remember what I said at the beginning. 10 millimeters from the left side here is my structure of the pedestal cabinet. So this area isn't backlighted or isn't easy backlighted. So light can't come directly from underneath to this position. It only can spread through the panel here. you will always come out with a little bit darker letters than all the others. So don't place it, here, this is what I'm calling you when you work with the handles. So don't place it too near to the side, always a little bit more to the inside so that enough light can reach it. So copy and paste it here and com with 2 M's. Okay. C-O-M-M. There we are. Zip. Here. And yeah, and the TFR we have there, we can place this too. Let's copy this again. The reason why I'm copying this here is because I think I don't have to select the font again. TFR. But this time one level smaller. Where have I my writings? Not the 4.66, but the 3.97. 3.97. Not much difference, but a little bit. And we'll sit somewhere here. Well, later I make all this aligning right. So, and com test. Now let's have a look again here. Com test. Is this again the? I think this is this and the small size too. Just thinking. Yeah, it's all these things that describe a button directly are one level smaller. This is how it was made on the overhead. So what need we here? Com test. Zip. There, whoop, there we have it. And here. So we had a ring around. Those rings around the cutout are always very dangerous. Can make them. I think I will make it. But just to remember how those panels are made, you cut them out first, then you take them away from the laser, then you paint them, and then you have to re-put it into the laser and align it to the laser head again. On the CNC, it's a little bit easier because on the CNC, there are some alignment tools which you can place here on the edge, and the CNC goes to the edges, and so it can calculate exactly where this edge is and how this panel is aligned to the CNC, and so it can calculate exactly where this circle is, and this comes out good most of the times. But with a laser you can't touch edges. And so you have to laser the outlines of the panel on a piece of masking tape or a piece of MDF that you lay underneath. And then you have to manually align the panel into this shape. And you can think this gives enough room for really small alignment errors. And so this circle, I think, is really hard to hit directly around this cutout here. Yes. Yeah, sorry for this. But we will do this. So go on here, and we can use the middle of the circle. So make a first circle 9, I think, yeah, something like this, 9 millimeters, and another circle so how big? Let's make 1 millimeter line. No? Mostly all these other lines here I'm doing. Let's have a look here. When we have here such spacer lines here on the cockpit, I'm using 0.8 millimeters, yeah, as the size of these lines. And for where have we these stripes here? For these stripes around the buttons, I'm using 0.7 millimeters, for example. Yeah. Maybe I can also use here 0.8. I think a millimeter can be fine. Oh, there we are. Anything missing? Stand by, TFR, no. Yep. Let's finish the sketch for now. And now we will do extrusion again here. And we will select these texts. And we will do an extrusion of minus 0.2 millimeters. There we have it. Minus 0.2 millimeters is also the extrusion depth I have used on my panels when I have routed them out with my CNC. Sometimes when you want to fill them with wax, there are some cases where you want to do this, especially when you want to have black engravings on a yellow acrylic, for example, like the master caution button. Then I'm using a little bit more, 0.4 millimeters. Yeah. So, okay, what have we here in the chat? A little trick that I do is pull the font sides all the way to the panel edges, or make guides at the edges of the area. Then choose center alignment for the text. Then the font is centered to the area. Oh, this is something we can try. Yeah, I have a case here where we can use this. Don't forget to explode the text. This keeps the font from having issues during the extrusion. How do you export the text for engraving? Okay, I haven't exploded it yet, and I haven't seen any difficulties until now. By the way, where would I explode this? Here, oops, which is the font there? This I call engraving. Yeah, come on here. Ah, explode text. What does this? Yeah, cool. Cool. Now we have, okay. Wait, I have seen this option explode text in other programs. Yes, I remember in Estelcam, my CNC control program there, when you exploded the text, I think this is the same here. Yeah, for all the others who haven't seen this too, when you explode the text, I think then you aren't able to edit the text anymore. No? So you can't make other letters here. No? So this you should do when you are finished with this. How do you export the... Sometimes font types have an issue when you try to extrude it. If so, alias says to explode it. But if it works, then you're fine. Okay, turn it from a font type to an outline. Yeah, genau, right? What I said, it turns from font type to an outline. Yep. Oh, when I'm thinking about this, yes, this could be an option. What I have done in Core Draw, I've added an outline. Now, oh, this is cool, guys. This session here was already useful for me, and I hope for you too. When I now mark this text, then I have here the offset option. I think, no, I haven't. You can do it only for one thing. Am I right? Come here. No, the sketch offset, create to geometry, modify the offset dimension or verify changes are correct. Ah, there it comes. Here. Can I do this with more than one letter? Offset. It needs a while, but yes. Oh, this is so cool. This is what I've... but it goes to the middle, to the inside. Okay. It's a negative offset. Okay, I would have thought it is a positive one. Minus 0.06. This is the offset that I have always used, so that the font is like the font comes out from my CNC router. Yes, okay. But okay, this is an additional step you would have to do when the font isn't how you need it, when it doesn't come out like you want it from your laser engraving. So you can make the text a little bit bigger, for example. But in my case now, it isn't, I'm not in need for this anymore because I have edited the font. And Broken Brain Guy, by the way, yes, I had problems with this MS33 font here at the beginning. And then I have edited the font and corrected all these failures. So when you do the editing in the font program, then you can see there are many points settled on in one area. I have deleted them and made clear fonts, and now every letter is clean when you extrude it. Okay, but for everyone here who searches for this option, explode text, fine thing. Cool. This is so cool. One of the best live stream ever here now. So, and it's turned to from genau. Right, I make a backup layer with a font layer, then a copy just to explode. Okay, because when you explode the text, then it is destroyed. So make a backup of it. Okay. You have no idea how many videos and sketch tutorials it took me to find all that. Yeah. I have an idea. I can imagine. So, but now let's go on here. The really fun comes now when we use an effect on these faces. And for this, you have to select these. It's a little bit tricky sometimes to do this. And be careful that it is highlighted. You can see when I come beside here, then the other parts are highlighted. So highlight the text. Oh, this is so cool. Always, I love this when this makes this really real. By the way, if anyone has a better option to select all these faces more efficiently, then just let me know. I haven't found any until now. And here we are. And now, ladies and gentlemen, here we are. Ooh, cool. Yeah, not too bad. So what would have we here in the chat? The fact that you just said you opened a TrueType font designer to fix a font just makes you a bigger hero to me. Yeah, and I forgot the circle button, right. Yeah, it's not too difficult to edit a TrueType font. It's just a lot of work. You can do this. Yeah, the circle. Here we have it. There we can do it. Oh, this was very difficult to make in. Oh, what is this here? To make in STLCam such a circle, or to export it in from CorelDRAW. So again, what is the problem here now? Ah, so faces. Yes, I have forgot to extrude it, right. So the extrusion, also the circle, please. Okay, and now again, color, faces. This doesn't work. Oh, really hard to hit this. What is this? Ah. Maybe it's because I'm on the back side of the... No. Heh. What's the problem here now? Tja, I don't know what the problem is here right now. Because the sketch was visible, and so I wasn't able to go through the sketch. So yeah, now we can do this finally. Here we are with a circle. The circle from the far away, it looks a little bit edgy, but when you come nearer, it is round. Yes, so here we are. let's come to the backlight panel. I think we won't come to this button here in this stream. It's a little bit more difficult to design it. Maybe we can make a first rough placeholder. This is something we can build here. Do we make this as an own component? I think. Yeah. Make a component and call it TFR for this transfer button. And yes, we will just make a simple box for this first, I think, with a measurement. I already forgot it. Oops. We orbit here a little bit strange. So again, 12 millimeters, and I think the height was 9 millimeters. Yep, 12 by 9, and we have to leave a little bit of space so the button doesn't stick and can move. Mostly I'm using 0.1 millimeters of gap. 0.1 around every corner. Sometimes it's too loose. So back here to the TFR button, and we make a box. Can we just, which plane? This is not good here. Box on this plane here. I can't reach it. Okay, it's the X and Y. So there we are. And we're placing a button. So we have 12, no, this is 9 by 12, and then subtracting 0.2 of this minus 0.2 is again the method how I'm writing it. So that I see I have subtracted something from this. A height of, it has to go through most of the panels. Let's start with 10 millimeters. I don't know how high this must be at the end. So and now make some fills around. The audience has said we should use 1 millimeter. There we are. And now we have to align it somehow in this hole. And again, using the align hole, you can use the join tool too. I think it's a little bit, and you need a little bit more resources when you do it with a joint. And I have made, I got really good results with this method here. So it's aligned to this here. And now it's getting really difficult, I think. No, again here, where we go too near. So we have aligned it so that the top and the bottom is right. Now it must go only a little bit to the left, minus 0.1. So now it's centered. And now we move a little bit down. It will stick out a little bit. I don't know how much. Just assume. So, color, black. We use plastic. Is this what is the English plastic here? I think they had a black plastic already here. Okay, we can just make an ABS and change it. So just bring it, we make this different duplicate and make it just black. So, and yeah, and do this. And then go back to our component here of the button, and we will make a sketch on top of it. Capture the position, and again, have fun with the text tool. No, not with the text tool. Sorry. Have fun designing a double-sided arrow. Okay. Have a look at the chat. When you do laser cuts, how much can you expect the laser to destroy when you're planning buttons like this for the transfer to make sure is enough give? Destroying is he's not destroying anything. It's really fine. So the width of the laser beam is 0.14 millimeter, something in this. So you shouldn't go smaller or nearer to edges here. But I haven't had any problems engraving small things here. The easy way to do the button is what Java said: grab the sketch of the hole and offset it 2 millimeters and extrude it. Then it's already aligned perfectly. Yes, my thoughts. I've thought of this. Yeah, I don't know why I haven't done this. Yeah, would be the easiest way. Just use a sketch. I think I haven't done this because when I'm editing the sketch and I don't want to edit the button at the same time, then I would have to make a copy of this. Okay. Now you can see my abilities to design an arrow. Okay. I think this would be not too helpful for you now. Just making this somehow. I will this do better later, an hour for myself. But for now, not too bad. Okay. Ja. It's not getting better, I think. something. So I'm just throwing in some constraints here. Yeah. Yeah, okay. I have to make these a little bit better, but not too bad. So it's oh, and they are bigger, much bigger. Okay, I will do this later better. Just now for you to see how this is done. And again, we will make an extrusion minus 0.2. There we are. And color on this face there. There we are with the button. No, something like this. Sketch layers, panel on one, cuts on another, text on third. Right, panel is one. Right, text is the engraving. Right, another sketch. Panel on one, cuts on another. What is the difference between panels and cuts? I think the cuts are making a panel out of this. But so for the arrows, you can use an arrow font and combine them on the layer, or pull an image as a guide and draw over it. Yes, also a good idea. Yeah, I will have to look at using a font that is looking like an arrow, and then we can use this explode. Then we have an outline. Yeah, and we can work with this. Yeah, this is also a good idea. So. Yes. Coming to the backlighting. I want to come now to the backlighting, so that you know how this can be designed. The problem with the backlighting is it shouldn't be in the way of any other component. I'm using hex standoffs, 50mm hex standoffs, so 50mm underneath the bottom panel, there will be the backlighting panel in most of the cases, and I hope this will work too here. One reason that I'm designing this panel is also that I can design the PCBs here for these 7-segment displays, so that I can order them and I don't have to pay the shipping costs every time I'm making one panel segment. So I hope really fast designing the areas where the 7-segment displays will be, and then design the PCBs, and so I can order the last PCB that I'm needing for the last segment of the overhead panel, to finish finally my overhead panel video series, and then order these at the same time. So my focus is on placing the cutouts for the PCB right, for the 7-segment displays right, and so having the outlines of the PCB. Yeah. So, and I have said when I'm using backlighting, then the screws for this backlighting panel will be 16mm away from these left and right corner to have enough room to come between these MDF holders of this panel. This is something where I go a little bit off of the original panel. You see this still in the bottom right corner. There are these 3 small screws that hold this panel together. The problem is that these 3 screws, when I would do them like they are here, they would do pressure only here and here. So this region, this middle region, would be pressed together, but not these outside regions. There are panels where the top and middle panel are made out of one acrylic segment. So just these cutouts here are routed out, and so these two top panels are one solid piece of acrylic. Yeah, you can route out these bigger holes on the back too. Yeah, but I'm doing my panels out of 3 layers, 3mm layers, and these layers have to be held together and pressed together so that not light comes out here or something like this. And these big screws here, which are mounting the panel onto the frame, in this case on the pedestal frame, are only giving pressure to the 2 bottom layers, not to the top layer. And I have to give pressure here, somewhere here, so that not the edges come up or are not looking aligned properly. And so I will move away the screws more to the sides so that the pressure is at the sides. Here. Where do we start? We make this start this on the top panel, because this is critical to place screws here, because they could in the way for any engravings or something like this. So back to our sketch here. My hose will be 3.5 millimeters. My screws have 3 millimeters, 0.5 millimeters for a little bit of play here, so that I have the possibility to align the panels a little bit. No. So what have we here in the chat again? I tend to draw one side, then mirror the other side. I think here, the engraving of the button, right? I agree totally. This would make sense. Panel is the outline of the panel as a whole. The 7 sec cuts and button cuts are another. Then text on third. Yes, makes sense. I think on such panels here where not too many cutouts are there, you can handle this in one sketch. But I would agree, if the panel becomes bigger, and especially when there are many different cutouts and complicated shape of the panel, then there are many lines and measurements in one sketch, and then it makes sense to separate the cutouts from the outline of the panel, right? So, Javier, I have a doubt about the screw cutouts. Only the front layer have to be cutted, or the middle need to be cutted too. I will do the screw through all these 3 layers. I don't know if I understand this right. So here we have 1 screw, and the distance of the edge is always 16 millimeters. And so I will do a second one. Which will be aligned to this. Okay. But the height, I have to think about the height. We will see. where this makes sense. In this case here, we can try, but I think this hasn't worked out on the last panel, to use these screws also as a fixing screw hole for the PCB. But the distance of the 7-segment displays is another. I think this won't work. So just make a first try. I think let's try here 5 millimeters, and also from here 5. I talk about these are screws. Yeah, the front layer is cut here. Cut it out, yeah. Okay. So here we have these. We will mirror these. Okay. We'll make another mirror. Objects, this circle. The mirror line is selected already. Maybe we have to change something later again, but as a first try out. Now back to the top panel. And to this is the extrusion. I think this first here. Up. And there we have them. Shouldn't forget to save from time to time. So here we have it. And now this hole goes through all the others too. And here we can use the projection again. Middle panel. Has it already projected it? It looks like. But I wouldn't know why it should have done this. No, we are at the top again. No, I think I have lost the overview here. Middle. We're in the middle. No. There it is. Okay, cool. I think it is because these two sketches are in the same not level. They are on the same plane, and so they have already this. Cool. Yeah. I'm not understanding everything what Fusion does. Most of the time, it doesn't help me when it does something, but in these cases, this helps me a lot. I just can use these holes. Okay. Sure, don't ask me how, but this worked. There are the holes. And you can see they are aligned perfectly. This is important. So, and now we can insert another part here, my spacer bolt. And yeah, here it is. I will turn it around 180 degrees. I will tell you why I'm doing this. But we will do a new component. Spacers. and there these spacers will be grouped into. So I've turned this around because the thread is on this side, and a screw will go through all these panels, and then it can be screwed in there. Now let's, how have I done this? Was it an alignment, or have I done this with joint? I think this was easier with a joint. I click on this face here, and then on this middle point here. So, and now I can join this with this hole here. And I have it exactly where I want to have it. Here, now import 3 others. I could also do a rectangular pattern, but I don't think that the screws are at the place where they should be later. They are looking really good where they are, but I'm not sure, and so I'm just inserting everything separately. But I'm can insert it. I can also make a copy of this here. I think this can be more easy. I just create a copy by moving. And yeah, this makes sense. Sorry, I'm just trying out some things. I'm measuring the distance. This to this is 55 millimeters. Okay, I could have calculated this too. Yeah, makes sense, 55. And I make a copy and move it 55. Yep, there we are. And now this here, from this to this, 115. Place this component directly in this spacer. So, and now we use these two. Create copy, move it 115. There we are. Spacers. Okay. And finally, a backlighting panel. My backlighting panels are made out of HDF board, something comparable to MDF, but harder. MDF is a medium density F, I don't know what is this in English, and the HDF is the high density whatever. So it is harder, and so these are boards that are used as back walls of cabinets, for example. It comes laminated white already, and so I think it helps to reflect even some light from that is emitted from the LED stripes, and yeah, is usable better as a backlighting material. Yeah. What have we here, broken brain guy? Sometimes I do parts like this. Divide the panel in half vertically and horizontally. Then place the item where you want and mirror it using the halfway points. Then 3 other copies are mirrors. Right. This makes sense here, especially here when we come out that it could be divided in quarters. Yeah. This can be done when you know from the beginning how your panel will look like later. Yeah. in this case, yeah, I'm developing the panel piece by piece. Yeah. So let's make a new component, but first, rearrange them underneath here. So, and now. I think we'll make a sketch. A sketch on this level here, because it will sit later here on top of these spacers. And we can use the panel outline I hope it doesn't stick there. We'll see if this works. Oh. It shouldn't be as wide as the panel. I think this won't work anymore here. Yeah, we have to not to build it on this point here. This won't work. Have you already? So away. No, okay. We have yeah, made the sketch here. Yeah, this is wrong. The sketch shouldn't be there. Oh, it's getting late, guys. And when it's getting late, the mistakes are coming. A new component, backlighting. And now the sketch on top here, like this. Ooh. Oh, and 65 and so, and this can't be as wide as the panel, because it would collide with the MDF where the panel is mounted on, and this here should have to go between these two things. I will show this to you when I have entered the measurements, then you can imagine this. So my panel had the width of 147, but I will subtract 12 millimeters on each side as space. So in total 24 millimeters. Like this. Yeah, and can I move this? I think not. Here, this is the problem. Why can't I move this now? Oh, I can do it. Okay. I move it over 12 millimeters. There. The height can be the same. It's not a problem. They fit together, but the width is a problem. So now let's cut these cutouts. We can project them, maybe. But where are them? The spacers away. Yeah, here they are. They are. And project these cutouts. Whoop. This and this. And now extrude it. There's a little bit. Why isn't it extruding this? I don't know. 3 millimeters. There we are. Spacer spec. And top panel. Ooh, there we are. A backlighting panel. And this would be the surface where all our LED stripes will be glued, so that they spread the light where it should be needed. And this is something here, when you look at the engravings at the side, what I said before, you can't place LEDs underneath here. It has to be placed here, and the light can go through the two panels here. They aren't completely painted, no? They are clear, and it can spread up here to the left, but not fully like all the other places where the LED stripes can be placed directly underneath. Okay, for all of you who don't know why I talked about the spaces here to the sides, this panel has to come into my pedestal box. This is under construction, and here you can see the panel will later sit on this and this rail here, and this rail has a width of 10 millimeters, and the backlighting panel has to be between these here, and so it has to be smaller than the panel on the top. Yeah, I think this is clear now. So, and there have to be cutouts for these components to let the cables run through here. So for this button here, we can look up this, what have I done here, backlights. Yeah, 12 millimeters for this, and you don't have to be too accurate here, but it helps a lot. But especially for big switches, for example, with the box, there you should let enough room so that the feet with the screws come through this backlighting panel. So don't come out too tight. Yeah, we can project it again. And we will, not the top, but the bottom. Huh? Yeah. Project the bottom there and use it to make a 12 millimeter ring around. And use this here in the extrusion. So there we have the first cutout. No, the PCB will not be too complicated here. Designing the PCB is a completely different topic that we won't cover here in this lesson. Something that we can estimate here is the dimension of the PCB. We will get rid of the backlighting panel here. I will place now a placeholder for the PCB here, so that I know the dimensions of the PCB, which I can use later in my PCB designing tool. I can show you again the PCB here of the latest panel I'm developing. or I have developed. Cockpit, where it is, overhead, forward overhead, the cabin pressure panel. There you can see the PCB sitting underneath. When we get rid of the backlight, there. This is a good example of a little bit more complex PCB shape, because here I have cutouts inside of the PCB to let light come through from the backlighting panel, which sits behind this, to illuminate these writings here over the rotary encoders. Here, I have to find out how this in the PCB making program can work, because the autorouter routes cables through this, and this won't work. But with this shape of the PCB, which I can export from here, I can go to the PCB making program. Oops. I will show it in short to you. So here we are with a PCB that came out. I have imported this shape then, and this helps me to arrange the components here on the PCB, and and later route the cables. And you can see the problem. By the way, maybe any one of you knows a solution here, why the autorouter wants to route the cables through these cutouts. Maybe I can define these areas as unrouted or copper-free areas, something like this. Yeah. Okay, but this is the reason why I roughly designed the PCB in Fusion 2. It would be better, Fusion gives you the opportunity to design the PCB directly in here, and then you have all the components here and so on. I have to dive a little bit more into this, but yeah, I haven't got into this, and other programs were a little bit easier for me to use. Yeah, and this is why I have chosen this export way. But it would be great to have, and I think this is possible, to have this one program, and you can do everything in this program. Designing this, you can make these electronic components, CNC. It has a slicer in for your 3D printer. I can give out the files for the laser and so on. Yeah. Okay, back to our COM panel here. And let's make a new component, which we call PCB. And I will design it on top of these 7-segment displays here. So yeah, as I have said, it would be great if these spacers could be used, but I think this will not be possible here. And so roughly I'm doing a shape around somewhere here, letting most of the text uncovered so that light can reach it. So just a short look to the chat again. You can create channels in the light plate with a laser to lay the LED strips inside. No, this isn't you aren't in need for this. I just you can watch my videos. I'm showing this in some of them. I'm just gluing them on this backlighting panel there, and this always gives me good results here. This way, this way you can plan the LEDs like how they do in real panels with the halogen bulbs. Great channels in the light plate. You mean placing the LEDs inside inside these layers? Yes. Whew. Yeah, it's the question how deep you want to dive into this. Yeah, right at the moment it's good enough for me really to just throw some LED stripes on it. Yeah, and Javier, you can delete that link. Which link are you meaning? This link, you mean when it was sticked to the origin, right? Oh yeah, this would be interesting. How can I delete the link to the origin? So during this, we come back here to this PCB. Here I have a little bit more space, and I think I should use this. So I will widen it a little bit. Not too much, because I will also need here space for this dual rotary encoder. I'm just estimating. I think I won't need, especially if I will, this will be a professional made PCB by a manufacturer. They don't need much space for routing wires. Yeah, just something like this here. Really, I will redesign this a little bit after this during the next week here, just to give you a sense of this. Yeah, I would say a little bit. How much I have to space it here. What is this here? No, this there, and I have to make here an alignment. Oh, there I can use this. 12 millimeters from this. I think for the hose, the mounting hose, I need a little bit space here. And from this to, I have to project the line here. And so I can use it with my measuring tool. 12. And this is only a guideline. So there sits this PCB. And to mount this PCB in place, there are different options. Just making here, how thick is it? I think 1.6 millimeters, something like this. Ooh, where is it? Right, yeah, here. Where it should be. To mount this PCB and so all the 7-segment displays with it in place, there are different options. The fastest and easiest option is hot glue. So you could spread hot glue in here, just here. It will be difficult to reach it here, and glue it in place just. I really think in this case this can be good enough. because it is not a really complicated PCB, and I think I will really do this. Just to show you another method, let's go back to the cabin pressure panel, how I have made this. Yeah, PCB, I get rid of this sketch here. Oh, where is this sketch that is visible? Here, okay. You see there are holes. There are also holes here in the bottom panel, but not on the top. So where are these holes? When we get rid of the top panel, then we can see them here. The holes are hidden screws, and we have 4 of them here. And can you see these? Yeah, you can see this. I have to look, not that I am covering something here on the screen. And I could have used the same method like I have done them here for the holes that press all the layers together and also hold the backlighting panel. I don't want to spread screws all over this panel, and so I have made the decision sometimes for hidden screws. And these go only through the bottom and middle panel and are countersunk. And there goes a countersink screw before you mount the top panel on it. And this will hold the PCB in place with a little 3D printed holder. You can see this in my IRS video. There I have printed these parts out, and these parts I'm using to hold the PCB in place and to be able to remove it really fast. I have to redesign the holders a little bit. They break really fast. But I think I can come out with a design that holds a little bit. Yeah, and this is the other method of holding this PCB here in place. Yeah, especially here, I think the PCB must be held good in place because you use force on these rotary encoders, otherwise they would wiggle. Yeah, but in this case, there is no force, no pressure on this PCB here, on the 7-segment displays. I think this can be enough just to glue them in place here. Yeah, as I said, otherwise you can place holes here through these 2 panels here and make holes into the PCB and mount it behind. I think I will think a little bit about this, have a look how much space I need to place all the wires. I will need a little bit extra space here on the PCB for pin headers for the connection to the cables of the Arduino. Yeah. Okay. Guys. What have we in the chat here? This way you can plan the LEDs. If you are not putting the stripes in a light specific panel, disregard my question. Okay. Yeah, this is how I'm designing and backlighting panels. Looking to the time. Here's how long was it? Yeah, I think late now, and I think there won't come too many new things here now. Let's just in that the button to see how this will look. Generate parts. Here's the button I want to use. And maybe I can use the link, the join there and there, in place. And you can see the nut is sitting inside of the bigger hole. Oh, this was fast, huh? And yeah, it's not looking like the real thing. I think, is it right how I've done this? No, I think it's sticking out too much. No, it isn't, huh? No, it isn't. Okay, I'm looking here at the overhead. Yeah, it's not looking like how it is looking in reality. In reality, only this, yeah, I think 3/4 of this black head are looking out of the panel. So not this here. No, this is a little bit too high here. So can I move this a little bit more down? Ah, okay, just only with this panel. Maybe I can delete this joint. Ooh. Only joints. Ah, okay, then it will throw it away. Okay, you just have to imagine this thing will sit in there a little bit more down here. It will look okay. Okay, yeah, the next task is to design a dual rotary encoder. Not today. I will have to think about this, and this will be a separate video of how to make this dual rotary encoder. Yes, guys, thank you all for joining this live stream here. I hope you have learned something from my workflow. I have learned today something too. It was really great that you have took activity. How can you say this in the chat? I have learned some new things, especially exploding text. Thank you. This will be a game changer here. Yeah, and I will have to write down some more shortcuts, so it will increase the speed here of developing. Yeah, and I hope everyone who is new into this topic and always wanted to know how all these panels are made, and this is something I can never do by myself, only big developers can do. I hope I have shown you that you can do this by yourself. It only costs you some time, and especially at the beginning, really much time doing this. Yes, this panel will be one of the first that will come into my new pedestal then, and you will see the upcoming video where I will produce this part, and you can say you have been here and seen the birth of this panel live. So Dennis Alvarez, very helpful, thank you. Yes, thank you all for being here, and I think now it's time to say goodbye. If you haven't done already, then subscribe to my channel to stay informed about any upcoming new video from me. And I hope we'll see us soon back on the flight deck.